Welcome everybody to Algebra 2, Section 5.6, Composition of Functions. So to start off today's lesson though, let's actually review function notation, something we've done before. So for function notation, we have things like f of x or g of x or s of t, etc. In all scenarios, the letter outside the parentheses is the name of the function. What is inside the parentheses is what you plug in. And then whatever is after that, there's an equal sign here that's written very poorly there, is what you output. So here, let's say if you did like f of 2, this would be 2 quantity squared, which is 4. So another example would be if you had f of x equals x squared minus 2, and you're finding f of 4, you plug in 4 to the function, which I would put that in parentheses, and get 4 squared, which is 16. 16 minus 2 is 14. So we would say that f of 4 equals 14. This is also a review on these 10 problems. So I would encourage you to go ahead and try finding that on your own, and then by pausing the video and then playing the video and checking what you have. So here for these first 5, we're using f of x. Above is 2x plus 8. So f of 3 would be 2 times 3 plus 8, which is 6 plus 8. So f of 3 equals 14. Reminder that you don't need to write the f of 3 on the left-hand side in the middle steps, as long as you have it on your first and last and you have the equal signs lined up. Next, we have f of 6, which is 2 times 6 plus 8, which is 12 plus 8, which is 20. So f of 6 is 20. Next, f of negative 2, that's going to be 2 times negative 2 plus 8, which is negative 4 plus 8. So f of negative 2 is 4. F of negative 5 is 2 times negative 5 plus 8, which is negative 10 plus 8. So f of negative 5 equals negative 2. And f of y plus 4 is a more unique one. So that's 2 times y plus 4 plus 8. We just plug all of it in. We distribute the 2 and get 2y plus 8 plus 8. And so f of y plus 4 is 2y plus 16, because we can't combine the 2y with the constants, the regular numbers. Down below we have more problems similarly, but we have a new function. It's s of t is equal to t squared minus 4t plus 1. We'll have to be careful with this t squared as we plug things in. We'll see what I mean when we get to problem, the third one here. So s of 1 is 1 squared minus 4 times 1 plus 1. So that's 1 minus 4 plus 1. So s of 1 is equal to negative 2. S of 3 is 3 squared minus 4 times 3 plus 1. So that's 9 minus 12 plus 1, which would be negative 2 again. Next, on s of negative 1, we have to be careful here as we plug in, as I was mentioning. Negative 1 quantity squared, those parentheses are quite important. Minus 4 times negative 1 plus 1. So if you don't put those parentheses here, you're probably getting this wrong. All around here specifically, because negative 1 times negative 1 is positive 1. If you don't type in the parentheses into a calculator, for example, you might read that your calculator would think that's negative 1. Plus 4 plus 1, and we get 6. So s of negative 1 would equal 6. S of the square root of 2 is the square root of 2 being squared plus minus 4 times the square root of 2 plus 1. Square root of 2 being squared is just 2, because the square root and square undo each other. Minus 4 square root of 2 plus 1. Combine the 2 and the 1, and so s of square root of 2 is equal to 3 minus 4 square root of 2. And s of y to the 4th would be y to the 4th to the second power minus 4 times y to the 4th plus 1. So we do 4 times 2 and get y to the 8th minus 4y to the 4th plus 1, which is our answer because we can't do any more math of combining terms because there's no like terms. Let's move on to composition of functions or function composition on this next page. So it says another, but let's just change it to a method since we didn't learn other methods. A method to combine functions is called a composition. So it's one of many methods. So given two functions f of x and g of x, the composite function or the composition of functions is f of g of x or f composed of g of x. That open circle is not a dot for multiplication. It's not an O. It is its own symbol for composition. And it's defined as f of g of x, or f composed of g of x, which kind of looks like the word fog, equals f of g of x with multiple parentheses. And essentially what happens here is we work inside out. So you plug whatever your x is into g, and then you plug that result into f. So let's practice this here on number 1. So for example, we have f of x is x squared, g of x is 3x, and we're asked to find what is g of f of 2. So that would be, once again, like I mentioned a moment ago, you plug 2 into f, and then you plug that result into g. You work inside out. So if I plug 2 into f, I get f of 2 is equal to 2 squared, and that is 4. So f of 2 equals 4. Then I take this and I plug it into g of x. So very similarly to like if I were to go to a restaurant such as like Chipotle or Qdoba or something similar, and I ask for, a burrito. And they, the first worker would get my tortilla and they prepare they might warm it up and they put rice on it, whatever else I'm asking to it at first, and then they hand it off to another person. So that would be like here, like the first employee had it and they hand it off to the next employee over here, which would be the next function. And the next employee doesn't just start over with a new tortilla and ignore everything that happened originally. They continue on with the tortilla. So in a very similar way, we don't just take 2 and plug it into here as well. Instead, we take the work that was already done and continue that work by doing g of 4 equals, and then plugging 4 in, 3 of 4, or 3 times 4 rather. Well, I guess of and times are the same thing in the scenario. But 3 times 4 is 12, so g of 4 is 12. This now means that g of f of 2 is equal to 12. And that would be our answer. You could also have it written as the g composed of f of 2 equals 12. That is also equally correct to write it how it was up here, with what is getting plugged in is second, and what is getting plugged into is first as far as the functions go. Let's take a look at number 2 here. So here we're asked to find g of f of -3. So we're plugging -3 into f and then plugging that result into g. So f of -3 is equal to -3 being cubed plus 2 times -3. And so that's -27 minus 6, which is -33. So now I take that result, plug it into g of x, and so g of -33 is equal to 4 times -33 minus 1. And so that's -132 minus 1, which means that g of -33 is -133. So g of f of -3 is equal to -133. Now notice both numbers 1 and number 2, as well as 3 and 4 actually, have you plugging something into f and then plugging that into g. If it were written like this, f of g of -3, you would get something different. Very rarely do you get the same thing when you switch the order of f and g and f. Occasionally it happens. There's actually a reason why it would happen when it does, but we won't get into that right now. But most often you'll get a different answer, and we'll see that here. So let's see what that equals to. So we first work inside out, plugging -3 into g. So we do g of -3, which is 4 times -3 minus 1. And I'll go and skip some in-between steps here of the 4 times -3 being negative 12, and just jump to that being subtracted by 1 and giving us negative 13. And now I'll plug that into f of x, so that's f of negative 13 equals negative 13 being cubed plus 2 times negative 13. And so I have to do here negative 13 to the third power. That means that I would get negative 2,197 minus 26 as I do 2 times negative 13. So that gets me f of negative 13 equals negative 2,223. So f of g of negative 3 is negative 2,223. Very much so not the same as negative 133. On number 3, we're doing g of f of 1. So we'll take 1, plug it into f, plug that result into g. So f of 1 is equal to 1 squared plus 1 minus 8. So that's 1 plus 1 minus 8. So f of 1 is equal to negative 6. Plug that into g of x, and g of negative 6 is equal to 6 times negative 6 minus 2, which is negative 36 minus 2. So g of negative 6 is negative 38. G of f of 1 is thus negative 38, as we stated. And on to our last problem here, g of f of negative 2. So plug negative 2 in f, plug that result into g. So starting off here, f of negative 2, negative 2 quantity squared, plus 6 times negative 2 minus 1 is 4 minus 12 minus 1. So f of negative 2 is equal to negative 9. Plug that into g of x, and I get g of negative 9 is equal to 4 times negative 9 squared minus a negative 9 plus 3. So that's 4 times 81 plus 9, as we do 2 negatives in a row, plus 3. So that is 4 times 81, which is 324, plus 12. And so g of negative 9, I just want to combine 9 plus 3 if you didn't catch that, would be 336. So g of f of negative 2 is 336. And that wraps up section 6 of Algebra 2.